Okay. So this is a presentation of Ethernet IP connectivity, as well as I will demonstrate with a Rockwell Automation Compact Logix PLC, configuring and integrating Danfoss drives into the PLC. So I will start with kind of an overview here of the Ethernet IP option. It is one of the Ethernet-based options that we provide for integrating to any of the PLCs. So the main features of the Ethernet IP option for the VLT or FC product line is a high performance Ethernet based option here, that has a high performance of a 1 millisecond return packet interval. RPI is a setting in the PLC, or a Rockwell type of terminology here for them. It does support unicast and multicast messages. It does include 2 Ethernet ports for line or ring type topologies. It is an advanced switch. It is a switch device. It's not like a hub, so it's not just a direct kind of just jumper connection as similar as you would have for like an RS-45 daisy chaining. It allows daisy chaining, but it is considered a 3-port switch, as you have a port 1, port 2, and the drive is a 3rd port, actually. It does support full CIP implementation, and that is another Rockwell term, as a communication, what is it, industrial protocol kind of thing. So it's more of, think of CIP as kind of the low-level communication. When we say full CIP implementation, this allows connectivity even with full class, instance, and attribute commands that can be used in other PLCs, or even the MicroLogix line of PLCs. It does have other functions built into it, as well as any of the other Ethernet-based options. When I say that, I am talking about, here we have the Ethernet IP. There's also Profinet, Modbus TCP. There is a BACnet IP, and EtherCAT, and I think there's also, yes, there's a PowerLink. They all share the same hardware, but the software is different, as it is protocol specific. But other functions, as it's a function of the card, they all have a built-in web server, which I can show, an email client for notifications of problems or alarms or warnings, and there is a function in here that we call the transparent socket channel. It's another port for communicating to MCT10 FC protocol, and that can be done at the same time as Ethernet IP in this particular option. Now, as I'm showing this option, there is one other drive that shares Ethernet IP, which is the FC 280, and that has the same hardware as this. It is not a removable plug-and-play option, as it is built onto the control board, and that the same goes also with the FCD 302, but it is the same hardware built on the board. It shares the same software and functionality. Okay. The Ethernet IP option has 3 LEDs on the left side of it. It is also, these LEDs are also broadcasted through onto the keypad, the LCP. The upper one is a module status LED. It green when it's everything's okay, goes yellow and red. It kind of follows the alarm and warning indication of the drive, as well as any faults of the card. Then you have 2 network status LEDs for port 1 and port 2. And they will be in different modes throughout the demonstration of connectivity, which I will demonstrate when we get to that. Also, the hardware MAC address is printed on the label, as well as there's a parameter to view the MAC address of the card. And the 2 ports are industrial graded RJ45, as there is a metal shield hood here that is connected to ground for shielded cables and ground connectivity of the cable. With the FC design, any of the communication options are the option A slot. They all plug into the top portion above the keypad connection behind the keypad. An overview of the concept design of the FC drives. A is field bus options. B are other I/O devices, more digital inputs, outputs, as well as connectivity for encoders and resolvers. And then there's also a C option on the side, usually bigger options. There's a larger relay board, motion control options, synchronizers, positioning controllers, and such. There is also a 1D option that we call down at the bottom, which is a 24-volt backup input that will power up the control section of the drive when AC is removed, usually used for keeping communications alive while safety contacts have disconnected power. So no way that there's power going to the motors while the safety is cut, but the Ethernet can keep communicating at that point. The Ethernet IP options in the FC drives are fully conformance tested and comply with ODVA standards and is certified. It has been certified since the design was implemented. Any of ODVA or Rockwell type of protocols are listed usually on the ODVA website, which I can show you how to view that. So if I bring up a web browser here, and the actual website is odva.org. If you go to the marketplace of this, you can search for individual products, and this covers all the Rockwell type of protocols, Ethernet IP, DeviceNet, CompoNet, and ControlNet. We support Danfoss, Ethernet IP, and DeviceNet, most popular machine automation ones. You can also search for a company through the member pavilion connection. And you can quickly click D, and you'll find Danfoss easily here. And it shows what we do support, Ethernet IP and DeviceNet. And when you click on that, you get just some simple communication or location, the list of the website, our unique ID number given to us from ODVA or Rockwell, and then quick connections to the devices. So when you go into the FC series, you can download the declaration of conformity as well as a link to the EDS file here. And any product, you can come down and it gives you all the specifications of what it supports. This is a good page also, as I will highlight at this time. At this time, we do not support SIP safety, CIP safety connectivity through the Ethernet IP at this time. I believe it's something we're working on, as we do have safety over Profinet, but not over Ethernet IP for safety PLCs. We still have safety connectivity on the drive through safe torque off, either through terminal 37 hardwire or a B option, as there's a programmable multi-channel safety options but not through a safety message protocol from a safety PLC. Okay. The I/O messaging channel, we support both a ODVA profile and a Danfoss profile, FC profile. The ODVA is a simpler profile. It is just 2 words in and out. There's a simpler control word and just speed reference word. It's just a single bit with a reset, just start, stop, and reset, and RPM commands. And status back is same thing, running or not, and RPM. Then there's an extended one, which has a couple more bits as far as reversing, control over through Ethernet or local, and the reference is the same. These are fixed, they can't be changed through the programming of the drive. This will need to be set in parameter 8-10 to be set to ODVA for these instances to be open. Otherwise, the default in the drive is the FC profile, which here we have the Danfoss 16-bit control word and 16-bit reference word, as well as the status and main actual value. The other instances that we provide add more additional programmable configuration data. So you can add, configure in the drive what you want these words to be. There's 2 when you use 101 and 151, or the full 10 words in and out at 103, 153. So you can add things like writing to ramp times, a whole host of other things, as well as reading most anything in the 16 group of parameters in the drive, like motor current, digital input status, frequency, temperature, other things. These lists can be found in the programming guide, as well as MCT10 you can view as setting up the drive. Through the CIP channel, any of the parameters can be read and written to through a class instance and attribute connection. Every parameter has a class instance and attribute addressed to it. So even if you're doing the I/O messaging back here, as 10 words may be somewhat limited, as well as configuration. Most of these are process parameters, but any of the parameters, including configuration of the drive, can be read or written through a explicit message through the CIP. The programming guide lists how to get to these. There's an appendix for all the CIP, but basically it's a little, if you want to say a kind of a math thing as far as setting up the class instant attribute for a parameter. So it's 100 plus the major group of a parameter for the class. The instance is 100 plus the rest of the parameter for the second half for the instance. And the attribute is 100 plus if there's an array or an index number. So in this example, like if I want to write to parameter 2-59, which it doesn't have an index, so it'd be class 102, instance 159, attribute 100. I would be able to read or write to this parameter. And the other example here is 5-34 parameter, index 3, so it'd be class 105, instance 134, attribute 103. These are support a get or set attribute single, or scattered for multiple. This is something you don't need to remember. Like I said, it is listed in the index of the Ethernet IP programming guide. In that, each of the different protocols have their own individual manuals to them. So Ethernet IP has an installation manual and a programming guide. If you're using something like Modbus TCP, it has its own installation programming guide. Any of the field buses have their own sub-manuals that go with the drive. The transparent socket channel that I mentioned allows connectivity through MCT10.
Joey, excuse me a second. Could you put it into
Yes.
presentation mode just to make it a little bigger for?
Oh, I'm sorry. I get used to not being in that. Excuse me. Sorry about that. Thank you. The transparent socket channel allows connectivity to MCT10. It is by default port 4000. It can be changed, both from the MCT10 side and the drive side. There is a parameter for it, but by default it's port 4000. But if there's any limitations or filtering from different ports, you can change it to allow. It can be used at the same time as Ethernet IP, as Ethernet IP talks on port 2222. The addressing of the drive can be set through manual or static set. That is the default in the drive. You can hard set it with the parameters to any list of IP address you want. It also can be addressed externally from a boot P server or a DHCP server. Most commonly it's statically set though, but it does support these other methods. With the 2-port switch, it allows connectivity. You can do a star just singly, or you can do a line or a combination of. Also, we do support ring topology, which let's go. With the ring topology, it allows you to have connectivity back to it. The simplest one that is made is called a spanning tree. It is a function of the switch. The switch is basically talking on one side and listening on the other, putting this on standby. When it detects that a drive is turned off, you lose connections to the others after the transmit side of things. It will see that the message isn't coming back. It will turn this back onto a broadcast, so you get the other half. This is a little bit now, can be kind of slow as far as the response time of spanning tree because it has some latency to it. We do support DLR, which is device level ring. That is the ring standard with Rockwell PLCs. This is a type of token passing, I say. They call it a beacon. Faster connectivity, as well as it can detect where the connection is lost due to the beacon has addressing on it. So every device, it sends out the beacon and every device responds back that this is me and here I am. And it knows when there's a loss when, of course, the beacon is lost and it starts communicating the other side. Generally with rings, it is still a line with a standby on the other side, just so you don't have collisions. Now, with any ring, I will say that any ring, there is a manager. It's not controlled by the drive as the drive supports it and can respond to, for instance, the beacon. But the DLR, it is controlled by a manager, the DLR manager, whether it is a switch with DLR control that is actually producing the beacon, or some of the PLCs now have 2 ports on it, and it has to be turned on in the PLC, as well as if there's a manager here. It isn't something that just happens automatically by plugging them in and plugging it back in. If it's not turned on, then you're going to have collisions, and it's just like a normal switch. And you'll have broadcasting on both sides, and you'll have connectivity problems. Now, also, as I stated, that this is in the ring, it's still kind of a line. And there is a limit to how many devices you can put in a line. There we go. So the recommendation is to have a max of 32 devices in a line. And that is mostly has to do with the latency of communicating from switch to switch to switch to switch. It's like note passing from the other. it isn't broadcasted the same as if it was like a daisy chain of a like a Modbus RTU, you know, RS-45 connection, and they're not hubs. So it's not like the message is sent here and they're all saw at the same time. It has to be brought into the first switch, it's passed to the second switch, third, fourth, and so forth. The switches are high speed that you can still maintain a 1 second return packet interval with 10 drives, but once you get beyond that, the return packet interval starts increasing. And I say it's safe up to 32 drives with the default in most of the PLCs at 20 RPI. But over that, you're starting to get too much of a delay back and you'll have connectivity problems either within the switches itself or in the PLC. And that's not just 32 Danfoss drives, it's mostly any device. It could be a combination of Danfoss and Vakon or Danfoss and any other things. And this is not a thing as seen with the RS-232 that you need a repeater. It's not a loss of signal strength as it is a timing thing. Parameter structure in the Danfoss drives, the FC drives, is most all of the parameters for the Ethernet IP in this case are all in the 12 group. When you install a Ethernet IP option in the drive, it is a plug and play. The 12 group will show up in there. The 12-0 is the IP address settings, as well as you have, you know, the DHCP or static, the actual IP address, subnet mask. Supports gateways. You can have the default gateway in there. It will list the DHCP server if it is using one, as well as name servers and domains. Also, as I was saying, there's a parameter there that's a read-only in 12-09 for the MAC address. The 12-1 group is the link parameters. It'll give you if there's a link status, something's plugged in or not, how long the communication's been there. There's a counter. Auto negotiation, if you'd like it to auto negotiate or not, of the link speed and duplex. It does support 10 base T or 100 base T and full or half duplex. With this in auto, these are read only and it will just show you. The 12-2 group is the process data. There's a readout to which control instance the PLC is sending to the drive and it's linked to, and the parameters for setting the extra words, as we call it, the PCD, process data config write parameters, and the read parameters. And then there's functions here for storing the values that are written to the drive in RAM, or you can set the store always. So there is RAM or flash. By default, when you set the drive to the keypad or MCT10, it is stored in flash, but things written from serial communication is just in RAM. So it will not keep settings through a power cycle, but you can tag this parameter and say anything in RAM, write it to the flash now. Store always, it's always on, and anything written from the PLC will be write to flash, but be aware with 1 millisecond possibility you can wear out the flash too much if it's always on. The 12-3 group has Ethernet IP parameters, which will list there's a warning parameter if there's anything or any kind of status of the Ethernet side of things. We'll tell you if it's in control or not, the reference or, you know, start, stop, or the reference, the CIP revision of the drive for knowing what revision of the EDS file, the electronic data sheet to use, as well as the product code listed to the drive. And each Danfoss drive, whether it's an FC 102, 202, 302, has unique product codes so that the EDS files are unique also. And the drive does support change of state. So there is a timer and filters for how much to broadcast back with the change of state. And these change of state is linked to the PCD reads. And then some parameters for turning on and off the other services, as we were talking about the HTTP server, the email server, and changing and seeing what the port is for the transparent socket channel. And there are some other advanced settings for cable diagnostics, broadcast storm protection. This is used for, let's say, a lot of broadcast messages on busy networks, keep it from getting flooded, and some interface counters. Some additional features that's built into the drive, like we talked about the auto negotiation, it's automatically on. There is an auto crossover function. You don't have to buy special cables or make crossover cables from going from drive to drive to drive, or even as I have linked here, I just have a standard cable plugged right into the drive. I don't have to do anything special. And we talked about I mentioned real quick, the broadcast storm protection, and is listed so you can filter out broadcast messages. Are there any questions at this time?
If you have a question and you're shy, you can always go through the chat function. I'll be monitoring that.
Okay.
If you're controlling from the network, what's going on with the keypad? The keypad functions, do they override the network or vice versa, or is that settable?
It is settable, and it is in the Danfoss drives designed. The main design is whether we are remotely controlling or we locally controlling. So that's where the bottom buttons on the keypad have a hand off and auto kind of function. So generally in the auto function, the control of the drive through the keypad is you are giving control to the PLC. If I walk up and press the off or auto, I am now taking local control of the drive, whether I am controlling it through Ethernet or through the digital inputs of the drive. So in the auto mode, it is controlled remotely, again, either through digital inputs or the Ethernet communication, as well as there's parameters even between those two on which takes priority, whether we are controlling it through digital inputs or serially. By default, the drive is set as a logic OR. It'll listen to both, but you can decide which way things are going. It's configurable. As well as there is configuration parameters for loss of communication, whether the drive reacts to if the connection's severed or we lose communication from the PLC. If the drive is to continuing doing what was last commanded, and that is the default of the drive, it will give a warning that communication is lost. Or you can set the drive to go to a certain speed, can stop and trip, can even go to a second setup if you have something like externally wired to the digital inputs for like a hand mode kind of thing with a potentiometer and a start-stop. The drive can switch to another setup. All right. So at this time, I am going to show you all this stuff. Don't expect everyone to remember all this stuff. Documentation is available on danfossdrives.com, as well as the field bus setup files. If I want Ethernet IP stuff, I can just search for it based on the different drives. Let's go to drives. And let's see, Ethernet IP. This one's giving me everything. Let's try documents, manuals. Oops, helps if I spell it right? There we go. That makes it a little bit better. So this is for the VLT, and there is for the Vakon product. The Vakon 100 has a single port built onto the drive, as well as there is the OPT EA card for the Vakon NX and Vakon 100, or the Vakon 20. I'd say everything I shown here is supported also on the Vakon side of things. The OPT EA option card is a 2-port card. It also does support, I believe it does support the DLR. I will look at that. It also supports this type in the Vakon side of things. It is one card that supports Ethernet IP, Profinet, and Modbus TCP, all on one card. You select what protocol you want to use in this particular option card. It does support DLR. There it is. Okay. And it does up to 1 millisecond also. The procedure of putting in this option card of the Vakon side is very similar to the FC product. I would say it's very similar to any product of any drive, varying non-Rockwell ones. Of course, the Rockwell drives are integrated into Rockwell software, but any product, you would have to get the electronic data sheet, EDS file, as well as Danfoss has provided add-on instruction blocks for adding on or making it easy to integrate the Danfoss drive into the Rockwell software. The add-on instructions and EDS files are available in the download section, all under the service and support area. So I can go to downloads, go to drives only, and there is a link here, third down. The My Drive suite is where you would download MCT10, and field bus configuration files for VLT and Vakon drives is where you would find EDS files, the electronic data sheet, and add-on instructions. When you click on this, the first one on here is our new add-on instructions for Rockwell Studio. And this is one block. There's 2 blocks actually in there, as well as it comes with a PDF instructions on integrating the drive, which I will be demonstrating, but it's all in this manual here. And it is supports for the all the FC products, FC 102, 202, FC 280. And a little bit lower down, we find some of the EDS file for the Vakon 100. And as I was stating, there's a lot of field bus things, EDS for the E9 or EA. And I may have flipped past, but there is also add-on profiles for the Vakon product. But I'm going to demonstrate, as I have here, a FC 302 drive. I have it already connected here. I brought up MCT10. Hold on, bear with me so I can make my size a little bit bigger here. There we go. Come on. There we go. There, that makes it a little more visible. So I have connected through USB a FC302 with the Ethernet IP card, but also as I've connected through the USB, we're talking about the transparent socket channel for Ethernet. I can connect to the drive via Ethernet also. I'm able to do both at the same time as with MCG10. Whichever one I click on is the one it's communicating, but you can see it's both the same. I am able to right click and click configure, and I can use the multicast to discover drives here. And even if they're not addressed, I will be able to discover them through the port 4000. They will respond by their MAC address. And I can set the IP address remotely here. Oops. Once I set any of the IP addresses, then I can go back to this and scan for drives. And I'll find the drive through its IP address here. But there's always, I still can plug in through the USB one at a time. If I'm connected to an Ethernet and there's multiple drives, like through from a switch, and it's whether it's lines or rings or whatever, I will find all the drives at once. I only have one at this time though. I can also address it directly through the 12 group. Can't through here as I'm on the Ethernet there, but through USB. It was grayed out there because I was connected via that. MCTN won't let me sever my connections, but through the USB I can set it here. Okay. See, I have it manually. I've set the IP address in the subnet mask. I don't have any other gateways. No need to touch any of the others. Right now, my PLC is not communicating to the drive. I can set other PCDs or process configuration data, let's say like motor current. And I can set any other. Other ones that I've highlighted, let's say like the built-in web page. Viewing that now would be just typing in the IP address now that I'm connected to it. I might have to cycle power for it to take effect. I will do that. So I just turned off my drive, powered it back up. What I'm waiting for is the indication on the LCP that there we go. Let's try this again. Alrighty. Well, it's mostly for testing and stuff. Let's move on at this time. All right, so I've set up the Ethernet. So now we will check connectivity through the Rockwell software. With RS5000 Studio or Studio 5000, RS Logix 5000 or Studio 5000 is what they've started calling it. One part of it that makes all the connectivity to my PLC and drives and stuff for setting up is RS links. It's linking everything. I have here a connection for Ethernet IP, and it starts looking and it finds product I've had on there. Being I had a 10 and I change it to 11, you can see the drive over here and it says, hey, I don't have a 10. It's looking for everything I've had before. I can just remove this. And if you don't have the EDS file installed at this time, you'd get a question mark. It would still have, there's a device out there, and you'd be able to see the properties. And as it would come up, I'm in FC302, my vendor is 97, which that's the Danfoss one. Product type 2, AC drives. The code, the actual product type, that's for FC302, it's product 1100. Its revision number and a kind of serial number. Once you install the EDS file, you will get the icon as well as this is the unique name that is in the Rockwell system for the EDS file in its database. For view here, let's go to my documents. Oops, not documents, files. So when you download the EDS file from the website, you'll get a zip with an EDS for all of the products that is supported. We'll go to the 302. And the EDS file is just a text document. I myself have set my Windows machine to always open EDS in Notepad. But once you open it up, you'll see it's a text document. Just has some file header, what the date it was created, but it has all the identification stuff here under device. So 97, given its Danfoss, number 2, AC device, the product code, the major revision 12, minor 12, or major revision 16, minor 12. It's an FC302 catalog number, and then the icon and some of the stuff that's built in the icon. And then below that has the linking data that we can drop down and select in the Studio 5000. As you may have noticed, the major revision 16, but in my drive was 14, and this says 12. As revisions change in the drive, some minor ones, the minor revision may change here. But mostly Rockwell cares about the major. The major is where all the parameters are the same. So I can also change my linking. I can use this for any revision if I tell Rockwell to not care about the revision number. So the EDS will still work. It will know that the product is the same. But we have the right EDS file for this drive. Since I'm looking at the files, there is, when you download the add-on instructions, as I said, you'll have the add-on instructions and a couple of the blocks here. There's a basic and a flexible, and I'll show both of them. So now that we have our drive here, we can go right into Studio 5000. And we'll create a new project here. Yes. Okay, so I have a blank project here based on my PLC, which is an L32E. It's a little bit old. I think the replacement now is an L35, but still works under this version. The version I am using is version 20, but most of all of the Studio 5000 on still looks similar as this. This has been looking this way since I've used it in version 13. So if I need to add the EDS file, you can do that through the tools in the hardware installation tool. this is actually shown in the programming guide, as well as if you're going right for the add-on instructions. The add instructions highlight this procedure graphically. Step by step. And everything I'm going to show you is in this manual. So once you get through this section here, it says, hey, everything's okay. Next, and I am done. Then you can add the device here, going down to the Ethernet port that I'm connected to of the PLC. I will right click and do new module. Then I can uncheck mark, just kind of highlight down to just the Danfoss product, or even Vakon product. With everything, I can also search for it. I'm looking for a 302. But once I find my product, I will click on it and create. I will give the product a name. And an IP address. Now this brings me up to the cards now can be of the FC302 can be hardware set through a dip switch. But using the dip switch on the card itself will lock it into this private network choice that Rockwell has listed here, a 192.168.1, and the dip switch is changing just the last octet. But doing it through the parameter ways, you can use any type of IP address scheme you want to use. Being I kept the same, I will go ahead and just check mark here, but it really doesn't matter. I can do it here, 192.168.1.11. Other thing for using, as I was saying, there's different connectivity, and you'll see it down here. It defaults to the 100, 150, the 2 words in and out. To change this, you will click this change button down here. And you will be given the module definition that is given here by the EDS file for the drive. If I want to change the words in and out, I can just click what's listed here and it will give me a drop down. So I can read and write 2 words, the 4 words, the 10 words, or the ODVA ones. Or even for some cases, if I just want to read only, I can set the drive for listen only or write only, actually. The drive is set, the drive's words in and out are 16-bit words, so I will change this. There is choice in Rockwell for SINTs, single integers, or bytes, as it would be. 16-bit integers, double words or real. The Danfoss drive is 16-bit integers, so that's where you see the 2 now. Before when it was single, it was bytes, but we'll do it in 16-bit. And like when I changed the other one, I said 2, 4, or 10. For using with the add-on instruction block, the block is programmed for 10 words in and out. So I will choose that. So when I press OK, at this time too, you can see the revision is listed up here. I can change it to match the drive. Or I want to be exact. Or I can disable that. But we'll do compatible. Compatible means it cares about this first part. Do I want to change? It's asking if I want to make these changes. Yes. And then you'll see it highlighted down here. Now I can press OK. Now there's other connections actually. This is where you can set the RPI. And see the default is 20 milliseconds. I can do unicast or multicast. cyclic or change the state, but I'll keep it at the default. There's other ones here for later, as I'm not live, I'm just programming the project at this time to be downloaded to the PLC. I don't see anything here yet. This is going to be read from the drive when it's live, as I'm right now in creating this. So I'll go OK now. Once I press OK, you will see it under the Ethernet, highlighted here as it has its part number of the card and the name I gave it. I can close this if I'm not making any more. Also, once I've created that, up at the top in the controller tags, those I/O instances that I created and how many words now is reflected up here in the controller tags. So I have the input words from the drive. Under data, I have 10 16-bit integers. And I have output to the drive, 10 16-bit integers. And as we know from the manual, 0 is the control word, 1 is the reference word. Coming back, I'll have the status word, main actual value, motor current. Now these word numbers line up with what we set up in MCT10. Move this over here. Let me open this up because I made it big. Word 0, CTW control word, word 1, reference word, word 2, nothing. Coming back as we set, word 0, status word, word 1, main actual value, word 2, it's motor current, or anything I want it to be. Say if I wanted to change ramp times. Lines up the same here. Okay. And at this time, if I didn't want to use the add-on instructions, I can literally just download this right to the drive, or sorry, not to the drive, the PLC. Slow connections. Can't help slow computer, right? No. Let me check my PLC connections. I know it's there. Let's try it again. Yes. There it goes. No errors, everything's there. It says I'm having trouble with my drive. Come on now. Because my window's so big now. Properties. Oh, I'm in there. Let's see what's going on. See, so I have a connection problem right now. I think I know what my problem is. I have it set for ODVA from the last time I showed. And remember, I used the 100 or 103, 153, which is an FC. Let's correct that. It would be the same kind of connection problem if I had it for FC profile and I tried to use the 2021. If I was able to show you, being I had a smaller area, down at the bottom you'd see it saying connecting and error, connecting error. Now that I fixed the drive to the default, actually, now I got an IO OK, and it is happy. So actual loss of communication will be shown from the PLC side. I also had blinking lights on the drive. I'm not showing you here, and now I'm getting the status word now from the drive. And I can literally control the drive now too. So at this point, being I know the bit structure though, and that is in the programming guide, I'm done at this point if I just want to do everything unique through my main routine. But let's use the add-on instructions. So to use the add-on instructions, and as it is highlighted also in the actual add-on instruction manual, but to add them on there, you will import them to the add-on instruction folder here. So we will import one. And I'm probably getting this because it's easier to do offline. Let's give it a second. There it goes. I can pick the basic or flexible. Let's bring in the basic first. So I just highlight it to whatever folder I have it in. Import. Just get a window with a little description, just press OK. And the block will be shown here. The add-on instructions that's downloaded from the Danfoss drive are open for editing. You can change parameters or go in the logic. The logic is written in structured text in this one. I can't open it as I don't have the editor installed right now on my machine for structured text. But if you install the editor, you can make changes to the logic or see what the logic is. Now, using the add-on instruction, it is simple as going to my routine, grabbing the block, and as I grab it, you'll see it visually show up. Drop it right on the tree here. And then at this time, I have to give a block a name, as when I create this block, it's going to make some more tags for itself to be used elsewhere. So I will right-click on here, create the new tag, give it a unique name. So we'll just call these tags for right now, but it could be anything, and hit create. Once I do that, it does give a description at the top, shows the name I just gave it. It fills in automatically the tags to all these parts, except for there's a couple that's still with question marks. And these are the areas it needs to get, or basically point to, where it's getting the COM status from, and as well as where it's getting the read data and the write data from, which is the drive that we called FC302. So we literally just click on the first question mark, got the down arrow. So this is going to be input from the drive. So connection faulted, hit enter. Goes to the next one, down arrow. Read is going to be still input the data, enter. And the output, write data. And as that, I'm done setting up this block. And as I said earlier, when I go to the tags, I collapse down the drive itself, tags, it's all the tags linked to the block. So I'm doing this live, I'll just go here and I'll say, I accept all these changes live. Let's put the PLC in a run mode. turns green. Now I see a OK, and I can control these tags elsewhere in my logic, but I can write right to them. So let's enable the drive. That drive is ready. Give it a run. It is now running. Give it some reference. Now this is in percentage with a couple of decimal places, so if I want to go full speed, and now I see the motor current. It is running. It's ramping up right now. Run on reference. If I make the drive go into some kind of alarm, got a fault here. I can reset it. Let's go and reset the drive. There we go. Starts running again. And I can stop it. At this time, I'm done. I hope this demonstrates it's a fairly simple procedure. But again, this is shown in this whole procedure is shown in the add-on instructions. Creating the drive, selecting the drive, the change, integer, change it to this, press OK. It is saying it here. Press yes every step of the way. So even if you don't remember this or view this video again, it is documented with the add-on instructions for using the add-on instruction, as well as the EDS file and the control word structure is in the Ethernet IP programming guide. Any questions at this time or anything that you'd like to see?
Yeah, I'd like to get a copy of the video.
I'm sure John Levine will share this to everyone.
Okay, all right.
Yeah, I'll be posting this to our website under the resources. Right now, a section called Other.
Okay.
Now the other stuff I did mention, the CIP, there's a whole host of class instance and attributes for starting and stopping the drive through other, say, micrologics or non-Rockwell gateways or other devices that supports Ethernet IP. You can start and stop the drive, but the other CIP for using all the CIP is an ODVA type of message. So the drive to use those will have to be set to ODVA. The only CIP messages that are open in the FC profile, and that was 8-10 by the way, the only ODVA that's open in the FC profile is the parameter still. So I don't have to set, they work either way within ODVA or FC profile. So I can do explicit messaging here also. I do have a document demonstrating that also. If anyone, which I can share today, along with the presentation. And it is another pretty simple step-by-step. So I have a explicit messages, and it's another kind of step-by-step. So creating a message box, another tag you'd have to create for where's that data, as this one's reading motor current or motor frequency. And then you have to set the message box for the class instance and attribute. And the same in this document, how to get to that. where you put them. Note that in Rockwell, the class and the attribute is in hex, so you have to convert from decimal to hex. It's just a requirement of theirs. And where is it going, that tag motor frequency? And then the connection, the path would be the drive name in this other tab. Once it's done, or the message box in the routine is activated, it will read the data. As well as this will now show also, this shows how to write. It's just a different, changing it to set, and this one's showing the ramp time and how big or how much data. 7 pages. Well, this for me, this concludes the demonstration and overview of Ethernet IP connectivity. At this time, again, does anyone have any other questions?
You can also do it as a chat if you're shy and don't want to talk.
I just did such an excellent job.
That's right. They're all experts now, Joe. That's great.
Well, like I said, I hope that no one has to be an expert, but because we try to document as best as I can, as well as anything missing or any kind of confusion, please feel free to reach out to me, jhammock@danfoss.com, or John Levine can pass it on, or maybe even answer some of the questions, as he's an expert also.
I wouldn't go that far.
But anything, but anything missing or anything like that, we surely invite feedback and help our documentation even better.
Thank you, everybody. Appreciate your time today.
Hey, thank you very much.
Okay, thank y'all too.
Thank you.
Have a great day.
Be safe out there, everybody.